Hello everyone and welcome to this video. Now that you have an understanding as to what directory traversal vulnerabilities are all about, we're going to be putting everything that we've learned thus far about this type of vulnerability into context, and more so a practical context. And we're going to be doing this through the use or by demonstrating how you can identify and exploit directory traversal vulnerabilities within a real-world web application. So this is something that I always like doing, as you can probably tell. I like covering the vulnerability firstly at a fundamental level, giving you an understanding as to the syntax or the methodology behind identification and then, of course, exploitation. And the real-world web application demonstration is always there to put into context what the vulnerability looks like, generally speaking, in real-world web applications. What does that mean? Simply speaking, or simply put, it means that I'm showing you what the vulnerability looks like in the wild or in the real world. And the best way to do that is through the use of a real-world web application. In this particular case, we're going to be taking a look at how to identify and exploit a directory traversal vulnerability within a web app called OpenEMR, which again is widely used in a particular industry. So it is quite an important web application. And this is a very good example that sort of gives you that real life context. So this particular video has a live lab associated with it. The live lab will not provide you with access to a Kali Linux system, so you'll need to utilize your own. In terms of tooling and what we'll be using to facilitate the exploitation, you just need a browser, a web proxy like Burp Suite or something, or an equivalent like Zap, and terminal, and just the ability to read exploit code. So you can use Windows if that works for you, or any other Linux distro. So you can choose to go through this video first and then the lab. The lab has its own documentation, but I'm going to be, sort of going through a little bit of my own methodology within this process. And I'm going to be approaching this from the perspective of a black box and sort of giving you tips and tricks. So you can fire up the lab, and I'll do the same, and I'll see you within my Kali Linux system. Alright, so I am back within my Kali Linux system. I've just opened up the URL that was provided to me by the lab. And as you can see, it looks like we have a login form here, and the web application is called OpenEMR. So the first thing I usually like doing is obviously getting an understanding as to what I'm dealing with here from a web application technology perspective. What does that mean? It means understanding what web server is being used. So is this being hosted on Apache or Nginx? Secondly, what front-end frameworks or languages are being used, what back-end languages are being used, as pretty much as much information as I can get just based on what has been rendered in my browser. And in order to do this, I'll be utilizing a couple of Firefox or browser add-ons that have proven to be very useful, which I explored in another course. But for example, I can utilize Wapalizer to get a generalized view of the aforementioned important aspects or elements that I typically check for. So for example, I can see that it's using HTTP2. In terms of the web server, it is utilizing Apache HTTP server 2.4.18. So this is most likely being picked up from the response that is being sent by the web server. This is quite common in misconfigured web servers, where the actual banner of the web server is sent back, as well as the server-side language, which in this case is PHP. That's typically sent back under the powered by or x-powered by response header. For the operating systems, it looks like there may be a little bit of sensitive information disclosure, where for some reason, and we'll try and find out how this information has been extrapolated, we can see it's running Ubuntu. So the actual underlying server is running Ubuntu. The JavaScript libraries are jQuery, and the UI frameworks for the front end are Bootstrap. So, okay, we know what we're dealing with here. This is a PHP-based web application. Whenever we try and open up the URL, it automatically redirects to interface login.php. The parameter site is equal to default. So site is most likely being used to specify a particular site. So this may have, multi-site support. And the bottom line is, in order to use it, we need to log in. Now, I don't know anything about OpenEMR, so let's try and, find out what we can find out. So looks like we have an acknowledgements, licensing and certification page. And in here, we actually have the official website. So if we open up their website, let's try and learn more about what we're dealing with here in terms of what this web application is used for. So we can see that OpenEMR is fully open source, free software, always and forever. Fantastic. So OpenEMR is the most popular open source electronic health records and medical practice management solution. OpenEMR's goal is a superior alternative to its proprietary counterparts, with passionate volunteers and contributors dedicated to guarding OpenEMR's status as a free, open source software solution for medical practices with a commitment to openness, kindness, and cooperation. Fantastic. I really like this. So it's, for all intents and purposes, it is an open source electronic health records and medical practice management solution, which means it is used by hospitals and clinics to manage patient records, schedule appointments, and pretty much everything related to health records that you typically find at a health institution, right? Or a wellness institution, if you will. Now, the reason why this is so important is because with this example, I'm trying to demonstrate that, real world web applications are used in very, very critical industries like the healthcare industry. And in this particular case, OpenEMR is vulnerable to a directory traversal vulnerability. And as a web app pen tester or a bug bounty hunter, your job is to try and find these vulnerabilities. And if you can do so in projects like these, you help make the solution better. So just a little bit of a tangent there that I wanted to go down. But yeah, we know what we're dealing with here, but we still don't know what version of OpenEMR is running on this particular, server. We have some general information here about, pretty much, you can see the list of contributors, the license information, as well as, additional info here. So that's not being displayed anywhere. Even if I check the source here, doesn't look like, we can find that anywhere. So if I say OpenEMR, try and find that. Let me wrap the long lines. We can see that, pretty much nothing there. In terms of some JavaScript code, the registration form, we don't have any filtering on the client side, which actually makes sense, but we have document.cookie being sent. So that's the default one that is set. And then I assume a PHP session ID is set to verify authentication. All right, so it says right away document.cookie is equal to the following path. Yeah, and then currently the submit action is handled by the encrypt form PHP function. So, okay, very interesting. So it's giving us a little bit of info here, but nothing too crazy. But we can see, we pretty much aren't able to find any references to the version. So what I typically like doing is performing a directory brute force just to see whether I can enumerate, some web server meta files or anything that could give me an idea as to what specific version of OpenEMR is running. So I'll use GoBuster and I'll specify directory brute force mode, and then I'll say URL, paste in the actual URL here. In fact, let me type that in correctly. So GoBuster directory mode and then URL, paste in the URL there, if I can paste it in at all. And I want to brute force, perform a directory brute force from on the root here of the actual web server. And then for the word list, I will utilize, I'll utilize the default derb one. So I'll say user share word lists, and I will say derb, and let's use common. Okay, so I'll say common, and I'll set the threads to 20 to speed things up. So there we are. We can start seeing, pretty much the results and their status codes. We're only looking for 200 status codes or maybe temporary redirects, so 301s, if you will. So it looks like we have an admin panel here, a build folder. We have the 301 redirects that point to the correct directory format here with, followed by a // So just correcting this here, which is good. It means the web application knows what to do with a little bit of malformed input. But what looks interesting here is, for example, the build folder is a status 200, which means we could have directory listing. Remember, this is from the root of the web server. So if I say build and I hit enter, it says that that's not found. Let's see if I hit enter now. Okay, so we have an XML file here. Very interesting. So it's, pretty much gives us a description here. And then a list of what I think are some plugins. And can we find what version of OpenEMR is running? No, it doesn't look like we can. Let's go back in here. So we have build CGI, which is interesting, CGI bin, common, config, contrib. So let's try common and config. So I'll say common, which it should redirect to the actual directory. And yes, we do have directory listing, which is, again, one of the reasons why Wapalizer was able to tell us, you know, that the web server is Apache 2.4.18 running on Ubuntu. So this is an example of two vulnerabilities. Firstly, this web application is revealing or is displaying server banners. So this info should, generally speaking, be hidden because it's revealing sensitive information. And secondly, directory listing, you know, is never a good idea because any of these folders could have very useful information that I could utilize, right? So we have common and then we have config. And under config, we have config.yaml. Pretty much just has jQuery specifications, and then services, pretty much the same. We take 2 steps back into common. Under compatibility, we have checker.php. And yes, okay, so these files we cannot access because we don't have the permissions to access them, or they're not reflecting any output back. So they may be running, but we have the connector.php script. Okay, so we don't get anything back. All right, interesting. So config, common, we have controllers, which we have taken a look at. We also have images, interface, library, let's say images, and yeah, so directory listing on this as well. Images, we also have library, if I can type in library correctly. And, ooh, interesting. We have some actually MySQLi log.php that isn't being displayed, eSign. So these look like plugins, so very, very interesting. Still no indication of the version of OpenEMR that's running, but we have formatting SQL.inc, which looks interesting. And this contains information of the SQL functions and classes for OpenEMR. So this is just the default in terms of what it sets. Okay, so globals, and then if I say username, if I say admin, yeah, so no mentions there of any credentials that, you know, we can utilize, but this is very interesting. We go back to the directory brute force. Okay, this is interesting. So we have a SQL folder. Let's see what that is all about. We could have some SQL dumps or some SQL files here that, you know, were used to create the database, and looks like we have some versioning here. So it starts from 2.6.0 to 2.6.1. So these are all upgrade SQL files that essentially upgrade the database whenever you upgrade OpenEMR. And it looks like the last upgrade was 5.0.1. And we have database.sql. So that opens that up there. And then we also have defaults.sql, database identification. Let me open this up. Downloaded that for 12 files, that particular file twice. So this is defaults. If I say username, I just make a search for username, so nothing in there. So we're going to try database de-identification. Interesting. Okay, so these just look like they configure the database. Doesn't look like it stores any credentials, which is sad, but anyway, we'll proceed. The one key thing here, looks like we also have match. That's, sorry, not match, but patch. Okay, so that just handles patching. But the key thing is it looks that we're most likely, or it looks that version 5.0.1 is the most likely version of OpenEMR running. Now, going back to the actual login page, we can search for default credentials, but we can try and bypass this, you know, to try and gain access and see whether we can enumerate that version. So we can also perform another quick web app security test to essentially check for weak passwords through a brute force. And we'll go for the highest level of access or the highest level of privileges, which is the admin user. And for this, I'll be utilizing Burp Suite intruders module just to facilitate the brute force. And I'll just copy this URL here. And we'll go into Burp Suite, and I'll open up the Burp browser because, again, that makes it much easy and, you know, sort of separates both workflows. So I'll open up the browser, and what I'll do is I will disable intercept just till I get to the login form. So there we are, and I'll just put in some test credentials here. So I can say admin, and for the password, I'll just say test. and I'll now enable intercept. Just hit login, and we want to send this to the intruder. We can see that the parameters and their values are passed in the body of the post request here. So we can see new login session management is equal to 1, auth provider is default, auth user, so auth user is the username parameter, the value is set to admin, clear pass is set to the actual password or what we specified there. So we've sent that to the intruder. Let's try and see whether admin is valid user, but we'll only try and brute force the passwords for the admin user. So in terms of the attack type, we'll go for sniper, and we'll add this here as a position. We'll now go into payloads, and we'll say the payload set is 1 because we're only targeting one position. The payload type is simple list, and I will utilize the default. I usually, for brute forces, start off with when I'm brute forcing login forms, I typically utilize the Metasploit word list first because they usually have the defaults you typically see when dealing with web applications. So I'll go into word list and then Metasploit, and I'll go for, let's see if I have it here, Unix passwords.txt, and you can see it just contains the defaults and some common ones that are likely set. In terms of payload processing, we don't need much. The settings is where we need to modify a couple of things. So this is where we are going to process cookies in redirections, because there is authentication here, and we always want to follow redirections in case we do get a successful authentication, because I don't think it redirects when we put in an incorrect password. So if we say, test and test here, let's pay attention to what happens. Okay, so there is a redirect if we put in incorrect credentials, which is interesting, right? So the bottom line is, if I go into Burp Suite now, and I'm just going to disable intercept here and let that go, so you can see invalid username or password, but we'll go into the into intruder, and we'll start this particular brute force attack to see if we can find any valid password for the user admin. So I'm going to let this go for a couple of seconds. All right, so the intruder has been going on for a couple of seconds, and as you can see here, we have the requests, and we can view the responses, and we can also render them. So let's take a look at, okay, so that just displays a white box. That's probably because JavaScript is not being rendered. But we can use the length here as an anomaly detector to see whether we have successful authentication attempts. And it looks like to this point, password seems to be working. And indeed, it looks like it's working because we get 2 redirects here, or rather 1 redirect, one of which sets the cookie. So the OpenEMR cookie, it sets the other one, which means authentication was successful. And as you can see here, if we render the second response, it looks like we logged in. So it looks like the default credentials for OpenEMR are admin and password, which is fantastic. So I'm going to stop the attack now, and I'm going to discard it. And we've found quite a few vulnerabilities, which is interesting. So now that we know that, we're going to try and log in here. So I'm going to say admin and password, and let's see if we can identify the version of OpenEMR now. So there we are. We log in, and as you can see, this is exactly what you'd expect. It is a electronic medical records or patient management system, but more so medical management system that has a flow board, a recall board, a patient client management where you can schedule visits, you have patient records, you have visit plans. Very, very cool. And a lot of clinics and hospitals and wellness centers, all, at least the ones I've performed pen tests, have all utilized this at one point in time. So very, very interesting. If we go into about, we can see that yes, it is running version 5.0.1 and variant 3. This is very important because OpenEMR utilizes a variant system, similar to something like the Linux kernel, where you have the version and then variants are just, improvements or patches or changes to a particular version. And now what this means is that we can start performing some vulnerability identification with a tool like, for example, SearchSploit, which will allow us to search for exploits locally or exploits on ExploitDB, but the locally stored version. So we'll say SearchSploit OpenEMR, hit enter, and okay, so it looks like we have quite a few vulnerabilities that affect OpenEMR 5.0.13. Now, this is no mistake. This lab is meant to test you on a couple of things. And again, in our case, we're only focusing on directory traversal, but as you can see, we also have remote code execution, which most of these vulnerabilities for OpenEMR 5.0.1 variant 3 look like they are authenticated. So we have an authentication bypass, we have remote code execution. We also have this one here, which is authenticated arbitrary file actions, which is the one that looks kind of interesting here. So I'm going to copy it to my desktop by saying copy user share exploit db exploits, and we want to go to the Linux directory, web apps 45202.txt, Linux web apps 45202.txt, copy it to my desktop. There we are. And I'll now cat it out. And okay, so we have a couple of vulnerabilities here. So starting at the very top, we can actually see the exploit title. So OpenEMR 5.0.1.3 arbitrary file actions. Released in 2018, we have the author, so Joshua Pham, insecurities, the Twitter handle, version 5.0.1 variant 3 and lower are the affected versions. This was tested on Ubuntu with OpenEMR version 5.0.1.3 or variant 3, if you will. So far, so good. This is an exploit that looks like it'll work on our version with no or little or no issues. And then we have the first vulnerability, which is the directory traversal vulnerability. Now, you might be saying to yourself, why are we seeing this with a different name, like arbitrary file read? Well, that's just another name for directory traversal. So as you can see here in the description, it says that in OpenEMR, a user that has access to the portal, which we do right over here, can send a malicious post request to read arbitrary files. And the technique here looks like it is directory traversal, because if we take a look at the vulnerable code, there's an if statement that says, so for example, if the value passed in the post request if the value passed as the value of the parameter for the parameter name mode in a post request is equal to get, and then we say then echo file get contents. So it's using a function called file get contents, which we can actually research on, because this will help explain a lot. And this is why I like exploits like this. I'm just going to open up the PHP documentation here.